have you ever really thought about, really thought about, the actual shape of the entire universe, or what happens deep inside a black hole?
Yeah, those are the big ones, the absolute frontiers.
Exactly. And for decades, physicists have been stuck on, well, two massive problems. First, these things called UV divergences in quantum gravity.
It basically means the theories just stop working. They break down at really high energies.
Like inside black holes or right at the Big Bang.
Precisely those places. You get infinities, nonsense answers. And the second big question
Is the overall shape, right? The global topology of the whole cosmos. What is it?
That's it. What does the whole thing look like on the grandest scale?
Well, today we're diving into something pretty ambitious, a new theoretical framework laid out by Preece and Batinen in a recent paper.
That's right, Invisit Reverendee. And it's bold because it claims to tackle both of those fundamental problems at once.
Which, if they're right, could genuinely shift our whole understanding of the universe's origins, its evolution, everything. So, yeah, let's unpack this.
Okay, so let's start with those UV divergences, the infinities. For ages, trying to merge gravity and quantum mechanics, well, it's been messy.
Messy how? Just bad math.
Essentially, yeah. At high energies, the calculations just explode, infinities everywhere, and worse, sometimes you get these mathematical artifacts called ghost poles.
Ghosts, like theoretical phantoms that break the physics.
You got it. They signal that the theory is, well, fundamentally inconsistent, physically nonsensical.
Okay, so how do Preece and Batinen get around that? What's their solution?
Their idea is called UV-Finite nonlocal gravity. It sounds complex, but the core idea involves a clever mathematical smoothing factor, an exponential thing.
Smoothing, like ironing out the wrinkles in the math.
Kind of, yeah. This form factor basically tames those wild high-energy calculations and makes sure all the quantum loop integrals, the tricky parts, actually converge. No infinities.
Okay, no infinities. That's huge. What about the ghosts?
Gone. Their approach produces what's called a ghost-free graviton propagator, so the theory becomes mathematically sound and physically consistent.
Wow. And does it still work for, normal gravity?
Yeah.
Like planets orbiting the sun?
Yes, and that's crucial. At low energies, the everyday scales we experience, their theory smoothly recovers Einstein's general relativity. It matches observations.
Okay, so potentially fixing quantum gravity is monumental.
Yeah.
But then they take this turn, right, into the actual structure of space itself, this fractal foliation.
Oh, this is where it gets really wild. It's a completely different picture of space. They propose that space isn't just smooth and continuous. Instead, they picture it as like nested layers, a fractal foliation. Imagine spatial slices, but each slice is a three-sphere, like a 3D version of a sphere's surface.
Like a nested three spheres.
And get this, the radii of these nested spheres follow a Fibonacci pattern.
Yes.
1, 1, 2, 3, 5, 8.
That sequence.
Yeah, Fibonacci sequence.
Seriously.
Like in nature, flowers and shells.
Exactly like that. And here's the really cool part, the golden ratio. That number intimately linked to Fibonacci. It isn't just plugged in. It emerges naturally from the mathematics of their model. Wait, it's derived. They didn't just put it there.
Derived.
Yeah.
It suggests space itself has this fundamental, discrete, self-similar structure, like a hidden mathematical pattern woven into the fabric of reality.
That's mind-bending. Space with a kind of mathematical DNA based on the golden ratio. So how does this fractal structure connect back to the overall shape of the universe?
It connects directly. They use some seriously heavy-duty math Ricci flow with surgery, combined with the Poincare-Perelman theorem.
That's the theorem Perelman proved, right? The one that solved a century-old topology problem.
The very same. A monumental achievement in mathematics. Using these tools, Preece and Batinen theoretically derived that the spatial slices of our universe must be a three-sphere, an S3.
So they're not just guessing or inferring from observations, they're claiming a mathematical proof based on their theory.
Exactly. It provides a rigorous, theoretically derived answer to the global topology question. It's a huge step beyond just saying, well, observations suggest it's flat or slightly curved.
Okay, this is incredibly deep. Fixing infinities, fractal space, deriving the universe's shape. But what does it mean for us? Can we actually see any effects of this? Is it testable?
That's the critical question, isn't it? And yes, there are potentially observable implications. One of the most exciting is related to dark matter.
Dark matter? How?
Well, you know how we need dark matter to explain why galaxies rotate faster than they should based on the visible stuff?
Right. Otherwise they should fly apart.
Exactly. Preece and Batinen suggest that their discrete fractal structure of space might naturally cause subtle oscillatory effects in gravity over large distances.
Oscillatory effects, like ripples in gravity caused by this fractal structure.
Something like that. And these intrinsic gravitational effects, stemming purely from the geometry of space-time itself, might just explain those galaxy rotation curves without needing any dark matter particles at all.
Hold on. So this theory could potentially eliminate the need for dark matter just based on the structure of space.
Potentially, yes. It's an alternative explanation rooted in the fundamental nature of gravity and space in their model. It's a massive implication.
Wow. Okay. What else? Does it help with things like the Big Bang singularity?
It does. Classical general relativity predicts these points of infinite density singularities at the Big Bang and inside black holes, which physically are problematic.
Right. Infinities again.
But in this theory, those singularities get resolved. They're replaced by regular finite structures, something like de Sitter-like cores, no more infinities.
So it smooths out the beginning of the universe and the center of black holes too.
That's the prediction. Now, testing quantum gravity directly is incredibly hard, needs insane energies. But the beauty here is the potential for indirect tests.
Like the galaxy rotation curve.
Exactly. Those effects, if they exist, could be searched for in astronomical data. It makes the theory phenomenologically testable, meaning we can look for its consequences in the real world without needing to build a galaxy-sized particle accelerator. And importantly, it doesn't rely on inventing new particles or extra dimensions.
That's a big plus.
Yeah.
So wrapping this up, what's the biggest takeaway for you from this deep dive into their work?
For me, it's the potential coherence of it all. The idea that these seemingly separate problems, quantum gravity, infinities, the universe's shape, maybe even dark matter, might all be linked through a deeper fractal and non-local structure of space-time itself. It suggests a radically different yet possibly unified picture of reality.
It really makes you think, doesn't it? Imagine a universe where things like dark matter aren't mysterious stuff, but just a feature of the way space itself is built. Definitely something to chew on.